I am stoked to be here with all of you. Thanks for joining me on a Friday, no less. We have such a great lineup for today. I've been watching some of the sessions and I'm going to keep watching them. I know my colleague and friend Mara is on at the end of the day, so I'll be on pretty much all day. So feel free to, during the session or after the session, add your comments from wherever you're streaming in from. I would love to help with any questions if they're related to this, or even if they're not. So with that, you might be wondering what I'm going to talk about today. I'm going to be talking about serverless full stack applications in Azure, but I'm going to put a specific focus on Azure SQL today. But what I want to comfort you all with is that everything that I do today, everything that you see today is actually part of a new learning path that myself and another colleague launched last month. So what this means, this new learning path, if I just switch to it real fast, what this means is it's all on Microsoft Learn, and each module, there are 4 modules, but each module has a built-in Azure sandbox, which means for free in 4-hour chunks, you can actually go deploy all this stuff without having to have credits or money or whatever to spend. You can just go play around with it, and you can do it like 20 times a day, so you're never going to run out of blocks. But this learning path was really meant to be built for either new developers or students or older developers that are trying to learn some new technology or some different technology, or even database administrators trying to get into the space of Azure. So I think hopefully there's something for everyone in what you're going to see in the next 45 minutes or so. So hopefully that's good. We're going to talk about really the full process of building a new application, starting with the backend, which typically involves some sort of database, going into the APIs that are required, the application that's required, and then of course, how do you automate deployment or CI/CD? That's a big topic these days, and we'll show you how to do that, at least with GitHub today. This is great, but for every project, I like to have some sort of scenario. So for this scenario, it actually came from a real world scenario of a colleague of mine, Davide Mauri, who helped me with this, trying to catch the bus. So, I think this is something we're all familiar with, maybe less familiar during COVID times, but typically, you are trying to catch a bus, usually to get to the office, let's say. Now, what happens when you try to catch the bus? So one of 2 things typically happens. You get to the bus stop, you wait for some unknown amount of time, you catch the bus, and then you head to the office. Or you get to the bus stop, you see the bus because you're just a little bit too late, you have to run to the bus, and then you have to wait some time because you actually missed the bus, and before you can actually take the next bus and get to the office. So this is a less than ideal scenario, and maybe this is something that we want to try to optimize given the modern world we live in. So we said, hey, everyone has a cell phone, or pretty much everyone has a cell phone at this point. What if we could have some sort of mobile application or website that had a map on it, and with this map you could see the buses you want to take, so the buses in maybe a few routes that you might want to take, and also you'd be able to see a geofence of where you're trying to catch the bus. So like, for example, maybe I want to catch the bus within like 3 blocks of where I live, so I could have a geofence there. And then even better than that, what would be great is if one of my buses in my routes entered that geofence, then I would get a notification. So that's kind of where all this came from. And another thing, just to show you all kind of the motivation, we found for the Seattle metro area, and actually a lot of relatively large cities provide this information, but they actually release a real-time JSON file that has bus information in it. So real-time live updates of where buses are. So they're leveraging some sort of IoT here, and they're just surfacing it on the web for us for free. So we know we have this, and we also have a flat file that's like a text file that contains all the different routes, and that's going to help us kind of coordinate which routes we want to monitor and then match it with this real-time data. So that's just an overview of kind of the motivation that went into this. And so what we did, like you kind of saw a preview as, is we built a whole learning path based on this idea. So we're going to go through each of it today. Again, we're going to go kind of fast, but I know that y'all will be able to follow along step by step in the learning path afterwards. That's my biggest call to action, is get hands-on, try this stuff yourself. It's free, you got no excuses. Yeah, so let's get right into it. We're going to start in module 1. We're going to be starting by talking about creating a foundation for modern apps. And to me, that involves selecting a database service. This is where we're going to spend a lot of time today because I want to make sure we understand some of the requirements and also what we have available. So for each step of this, you can see the breadcrumbs down in the bottom. We're going to track the database, the API, the application, and then ultimately the solution. And for each step, what we're going to try to do is understand the overall solution requirement and then what necessary information specific to what we're trying to do we have. So if we think about our solution, there's 3 main things. We want a website to monitor real-time bus locations. We also want notifications when a bus is close by, so we know when to leave our office or our apartment or house or whatever to catch the bus. And then we want deployment automation. So we're just getting started, but as we enhance this application, enhance this database, we want to be able to automate that deployment in a way that's scalable, reproducible, and also able for us to monitor if anything went wrong. All right, so when we think about the database service, we can first start by thinking about the data that we have. So we have some real-time bus data, which is stored in JSON. You just saw an example of that file. And then we also have the route data in a flat file. All right, so that's kind of what we have going into it. But I want to step back and think about, in general, what are some modern database requirements for applications like this one or other applications in general? Now, I think a big one is this idea of serverless, right? So when we talk about serverless, that means that we want auto scaling, meaning we only want to pay for what we're using. We don't want to pay for provisioned stuff that we're not using at the time, but we don't want to under provision and then not be able to perform when our app or workload gets heavy. Now, we also want to support development workflows. CI/CD, DevOps are all huge and very important topics these days. So we want to make sure that whatever database we use is going to help us in this development workflow that we're trying to organize. Ideally, especially for this scenario, but many scenarios as well, like you need Json support, right? A lot of information is coming in the form of JSON, so you're going to need Json support. And for our scenario, and a lot of scenarios are using locations for various things, but for our scenario specifically, we want to be able to support geospatial queries, geospatial data points. We'd love it if whatever database service we select is going to have built-in functionality. Because if it doesn't, then what we're going to have to do is we're going to have to, in whatever language we're programming in, we're going to have to do some extra work, find some libraries, figure out how to do the geospatial thing ourselves. And this isn't a big deal, but if it was built into the database service that we pick, it would just make our lives a little bit easier. And then finally, you want to future-proof your application. So we want to know not only is this database service going to be around for the next 5, 10, 15, et cetera years, but is it going to keep improving and advancing as technology advances? And for that, my recommendation, maybe you all saw this coming, is Azure SQL. And specifically, I think Azure SQL Database is going to be great for this. And there's a few reasons for this, okay? So big reason is that Azure SQL Database today is the only Azure SQL deployment option that supports both serverless and hyperscale. So this means if you start out with a small application or you're just developing your application, you can start in serverless and only pay for what you use. And I'll show you what that kind of means. And then if your application gets really, really, really popular, which maybe my bus application will, then you can switch to hyperscale, which is going to allow you to support databases up to 100 terabytes in size. And really, in theory, that's just a number. There's nothing physically or architecturally stopping us from going bigger than 100 terabytes. So that's one way you can future-proof your application. Also, Azure SQL Database has native JSON and geospatial support, which is going to make our lives easier in this scenario, but also a lot of modern applications are using both JSON and geospatial or graph or key value, even XML. These are all things supported natively in Azure SQL Database. Versionless is also another big one. This means that you never have to update SQL Server or whatever SQL you're using again. All of that, making sure we don't break you, that sort of thing now falls on Microsoft. And you're just going to get the latest and greatest updates and keep your application running and fast all the time, including high availability like an SLA and other things. And for anyone watching that already has T-SQL skills or SQL Server skills, I know that's a lot of our data community, you could just leverage your existing skills and kind of move to this more modern type of database. Lots of other things here, but I think a lot of people see themselves moving towards non-relational databases or purely NoSQL databases, and I think that's fine, but I also think that the relational engine is still the backbone of everything, to be able to guarantee ACID, to be able to do CRUD operations, to be able to have tables and indexes to increase your performance. All these things aren't going anywhere, so it's nice that Azure SQL Database is built on this SQL engine that's been around for almost 30 years, as well as is enabling you to kind of touch some of these NoSQL topics that previously might not have been possible with a relational database. So all that being said, let's talk a little bit about the JSON support that we have today. So one of the things that we have with JSON support today is some built-in functions. So things like isJSON, JSON value, JSON queries. You can also basically take in JSON and transform it into a table, or vice versa, take a table and transform it into JSON. And this can be nice for both ways. Taking in JSON becomes really easy, but also if you want to push JSON to an application, it also becomes very easy because you can actually specify how that JSON is going to be returned. So that's just going to make it a little bit easier for you to process once you're back in your application. Now we're going to talk about some of the geospatial support. I'm going to show you in a demo actually, so I'm not going to talk too much about it now, but it is important to note that we have geospatial support by default, so you don't have to install anything else, you don't have to pay for anything else, you just kind of get these capabilities. And with that, let's take a look at Azure SQL Database. So the first thing that you're going to do in the learning path is focus on the database, and you're going to configure your development environment. So I'll show you all the tips and tricks I use for when I'm developing with Azure with all the things you're going to use today. And then you'll deploy and configure your Azure SQL Database and automate updates. So just for time's sake, I went ahead and deployed this database. In the exercise, we're using scripts to do that. You could also use the portal. But what I want to point out is this pricing tier. So what we have here is we have a serverless database, like I was mentioning. And when it loads, what we're going to see is we're using serverless compute. So that means our compute resources are auto-scaled and we're billed on a per second basis for what we actually use, including the max of CPU or memory at any given point. And what we're going to do is we're going to scale, they're going to scale us on a per second basis between our min and max, so we can set those. And optionally, what you can do is you can set an auto pause delay. So here I enabled auto pause, you don't have to, with an auto pause delay of 1 hour. So if after 1 hour, no one touches this database, then what we're actually going to do is we're going to separate the compute from the storage. We're going to shut down essentially SQL Server running on the compute side. And during that time, you're only going to pay for the storage. So this is drastically going to save you money. Now, when you ping that database again, the first time it will fail, and it'll take about 30 seconds to wake back up again. Basically, we reconnect the compute and the storage. And then you start paying at the minimum level, and we'll start back to auto-scaling you between what you need. One thing to keep in mind with this, for all you data people, after a pause state, when it comes back online, you are starting with a cold cache. So that's something to keep in mind if you're looking at using this. But we're seeing a huge amount of adoption of this serverless capability, so I really wanted to make sure that I showed it to you all. All right. So the other thing that I wanted to show you before I X out of it is this idea of the app CPU build. So I told you when the database is paused, you're not going to be billed for CPU. So you can see earlier this week, I wasn't using the database because I wasn't, working on this application, and I wasn't billed for CPU at all. Wednesday, I hit it a few times, so you can see I was billed a little bit. Same with yesterday, and then today as well. So you can see how it's going to give me cost saving. Because if I was using the provision compute model, I'd be billed at this rate up here, whatever I provisioned, the whole time, even though I'm not even using the database a lot. So this is really useful. All right, so the second thing I wanted to show you is the geospatial support. So if you go through the exercises, you're going to get access to this SQL Notebook, which you can open in Azure Data Studio, like you see here. Hopefully you're all familiar with this. It's an awesome tool. I talk about it all the time. Basically, it allows you to mix text cells with code cells, and you can pick the language you want. So if you're a data scientist, maybe you're familiar with using Python or R notebooks, but now you can use PowerShell notebooks or SQL notebooks. Super powerful. All right, we're going to stick to SQL for today, and we're going to take a look at some of the JSON support. Now, what I did here is I just brought in some of that JSON data, just a sample of the JSON data that contains the real-time bus information. Just want to bring in a sample of it and start to work with it. So I'm calling it a payload. It's just straight JSON data. We can even see there's some nesting going on with the position. And now what I'm going to do is I'm going to use this geography point nomenclature to basically bring in the latitude and longitude as a location, and I can even specify the standard that I want to use. So that's really nice. It's just out of the box. So I'm going to bring in this JSON data using the open JSON T-SQL function, and this is going to allow me to bring in those things and specify how I want that data stored. Now, if we take a look at it, we can see the direction, the route, the vehicle, and the location is now taken the latitude and longitude and stored it as this value that doesn't mean a ton to us, but it allows us to store it in one place. Now, what I can also do is I can take that location, so take this weird funky number binary and convert it to a string, and that's going to give us this point value, right? So now what I can do is I can take this point value and go into a tool like this, and I can actually plot the point on a map. So if we zoom out a little, we can see this is somewhere on the east side of Seattle, kind of close to the Microsoft office, which is over here. All right, so if we go back to Azure Data Studio, this is cool. We can plot points, but we want to do more things than that. So another thing you can do, just to show you a few things out of the box, is this ST distance. So I'm basically saying, what's the distance between bus 1 and bus 2? And sure enough, I'm able to get that in meters. So for certain applications, this could be useful. Now, another thing that you can do, which is pretty cool, is you can also plot polygons. So here you can see I'm using a polygon, and we can actually bring that in and store it, in this case, again, with the standard as a geofence. So this is the geofence I was talking about, and we can even take a look at that in a minute. So we can now have this geofence, and we have points. Now, what do we want to do for our application? Well, we want to know when a point or a bus enters or exits a geofence. So fortunately for us, there is a way for us to put the points and the polygons together, basically using a geometry collection. And then we can use this st_within function, which is going to say, hey, for this location, is it within the geofence? And we can basically select that as a yes, no, so a 1 or a 0. And if we take a look at this one, for example, we can see that this bus is within the geofence here, right? That's my geofence, that's my bus point. It's within the geofence. So in Azure Data Studio, what we see is the in geofence result is 1. And similarly, just to do a sanity check, we can do it for this one. And we can see the bus is down here, so it's not in the geofence. And we can see back in Azure Data Studio as well that it's picking that up as well. So this is pretty powerful. All right, so now that we've seen this, what we're going to do is we're going to add some stored procedures. I'm not going to walk through all that. We're going to add some stored procedures so that our database is capable of taking in the data, storing it accordingly, processing it, and letting us know which buses are in or out of a geofence at that given moment. Now, what we can do is, since we already configured this on another database, is we can leverage something called a DAC pack, which you can generate using something like SQL package. Now, what I've done is I've stored the DAC pack in my GitHub repository, but I've also included a YAML file, which is basically instructions on how to deploy or redeploy the schema on my database. So what you can see here is every time a push or a pull request is made on this repository, we're going to run this deploy database job, which is using the Azure SQL action. It's going to connect to my Azure SQL Database server. We have the secret or the connection string stored securely within the repository. And we also have a reference for, hey, where is the DAC pack within the repository? So if we go over to some of the actions, you can see I did this one just before this session. We can see what it's doing is it's finding the DAC pack file, it's publishing it to that database server, it's updating the database, and then letting us know that it was published successfully. So this is a way we can automate the deployment and updates to our databases. Or if I start a new dev environment and I want to be up and running with the right schema, then I can just leverage this. So really cool, powerful stuff. We saw a lot in that one demo, but hopefully this was useful for you. Now, one thing we didn't take a look at is importing the route data into Azure SQL Database. This is very similar to what you would do in SQL Server if you're familiar, except instead of importing from a file, we're going to be importing from Azure Blob Storage. So there's an exercise that goes through how to do that as well. All right, so if we take a look at our architecture so far, what do we have? So we have buses which have IoT devices on them. Now, this isn't something we had to configure because ultimately they're producing, the Seattle County Metro in this case, is producing a JSON document that contains all that real-time bus information. We know that we can process that bus information in here and store that bus information here and identify if something is or is not in a geofence. We know that we can do that because of the example you just saw. We also created some stored procedures with that DACPAC file that can do that for us without me clicking manually each time. Now, we talked about how we could also get the route reference data into Azure Storage and then use T-SQL to get it into Azure SQL Database. The next thing we need to understand is, okay, how are we going to regularly keep the data in Azure SQL Database up to date? And for that, we're going to need some sort of API to basically call this new JSON document and bring in the new data. That brings us to Module 2, where we're going to talk about serverless APIs. We're going to talk about things like Azure Functions and Azure Logic Apps. And just checking the questions, keep your questions in, coming in. I see one comment about Clippy. Yeah, I did get to meet Clippy a few years ago when we were back in person. It was pretty cool. All right, so we talked about selecting a database service. The next thing we need to think about is selecting an API service. So remember what I said. I wanted to start with the solution requirements and then dive into each component of that. So down at the bottom, you can see with the breadcrumbs. We talked about the database. Now we're going to talk about the API. So again, overall, we're still looking for a website. We want notifications, and we want deployment automation. When it comes to the API itself, we want the API to go get the latest data from that JSON document, identify buses in the monitored routes, and also identify geofence activation. So again, we don't want to monitor all the routes, only the routes that are relevant to me as a user that I want to monitor. And then we want to send an email notification for each activated bus. So I'm calling a bus activated if it enters or exits a geofence. For this, I think we can use Azure Functions. And if you've never played with this before, I highly recommend it. It supports a lot of different languages. It also supports different triggers. So for example, you could have a queue trigger, you have a timer trigger, you could just have an HTTP trigger. So it just is triggered when you call an HTTP request. But in this case, we might want a timer trigger, right? Because we want to keep our database up to date. And the great thing about functions is that super easy to configure because you just deploy them and they are serverless and they will scale on demand. So they'll scale up, they'll scale down based on what you need, and you don't really have to worry about configuring it. Makes it super easy. So this Azure function, what do we need to do? So I'm trying to understand the requirements a little bit further. So let's say every 15 seconds, I want it to do the following things. Determine what the monitor routes are. Because again, we don't want to monitor all the routes, just the routes that we care about or our users care about. Then we want to get the latest bus data, and we want to store it in Azure SQL Database. And then maybe with Azure SQL Database, with those stored procedures, we want to trigger some of those stored procedures in Azure SQL Database to identify if any of those new buses or routes are activating a geofence. And then once we identify, hey, maybe route 2 is activating a geofence near me, then I want to send an email notification saying, hey, go catch the bus. Your bus is almost here. It's entered the geofence. And for that, we haven't talked about a good solution for that yet. Now, I know that there's a lot of great developers watching this probably, so you could go in and write this from scratch. More power to you. But what if I told you there was a way that you could do this without writing any code, right? Just connect to Outlook or Gmail or SSMS and just configure your connectors and go. Well, that's what Azure Logic Apps can do for you. And this is a really powerful tool, especially for folks who, I wouldn't say are lazy like me, but don't necessarily want to reinvent the wheel if you don't have to. That's what Azure Logic Apps is great for. It is also serverless and scalable, just like Azure Functions, except it is a low-code or no-code development platform. I'll show you a look at the Logic App Designer and how easy it is to use, and they have hundreds of connectors. Sure, they have connectors to SQL Server, Azure SQL, Outlook, SSMS, Salesforce, Gmail, all the sorts of stuff, Twitter, and you can just connect up, and it just makes integrating things really simple. So with that, let's take a look at our solution so far. So where do I want to start? So let's start by looking locally. Now, the great thing about Azure Functions is you can run everything locally before you deploy it. And that's really nice because it just helps you debug and test things easier without even paying any money. So what I have here is I'm in Visual Studio Code, and I'm in the repository for this application that we're using. What you're going to see is for every step, we've actually coded it up in .NET, Node, and Python. So you can pick whichever language you're more comfortable with, or since we wrote them all side by side, I found it was a good learning exercise to learn a new language. For example, I helped write the .NET and the Python section, but my colleague wrote the Node section. And by working together and seeing, okay, this is how you write it in Python, this is how it translates to Node, it was really useful for just learning more about Node. For local, what I'm going to do is I'm going to use the .NET version of the Azure function. And down here, I'm actually just going to use func start. There's a lot of built-in libraries and packages and extensions that you can use locally for developing. And while this is kicking off, I just want to show you a glimpse at what the code is doing. So this is a timer trigger, so it's running every 15 seconds. And it's basically going to process the bus data. So what does that mean? Just really fast, I'm going to show you what that means. What that means is, first, we're going to get the real-time feed. So we're going to use that JSON real-time document you saw earlier. So like this, we're going to pull this in, and then we're going to get that data as a feed. We're going to return the feed, and from the feed, we're going to make a connection to Azure SQL Database, and we're going to get the monitored route. So actually, before we do something with the feed, we're going to figure out what routes we want to monitor, and we're going to take note of that. Now, what we're going to do with the process geofences method is we're going to take in that JSON data. So this should look pretty familiar. It's very similar to what you saw in the first demo. We're going to take in the JSON data and add it to our Azure SQL database using this stored procedure called add bus data. And the result of add bus data is going to tell us, for those monitored routes that we've picked up and the new data coming in, how many buses are activating a geofence, and maybe it's none, or how many are on our monitored route. So for example, we can see this is running locally down here, and here, for example, we can see there's 443 bus positions, but 5 buses in our monitored routes, and 0 buses activating a geofence. All right, so if a bus was activating a geofence, then we want to trigger a logic app, which I haven't shown you yet. We want to trigger a logic app, and we want to send the logic app 2 things. We want to send it the vehicle ID, and we want to send it the geofence status. So basically, what vehicle should I look for, and is it entering or exiting the geofence? So that's basically what we're going to do, and then we're going to call the logic app. So you can see here that's a logic app URL. So I've actually gone ahead and published this, so I'm going to cancel it here, but I published the Python version. So the way I was able to do that, again, we're using these YAML files, and you'll see there's one for each language. But the Python one simply, uses the Azure function package path, which is basically saying, okay, where's the code? And it's also using the function app publish profile, which is basically like a connection string to your Azure app, Azure function app. And then it's basically going to deploy all this to Azure Functions for us. Now, it's pretty similar for .NET or Node. It's just slightly different in basically which action you're using. So here we're using the .NET one as opposed to a Python one, as you see here. All right, so we've used that to deploy this function. So in the portal, what you're going to see is I've got this function app here. You can see the execution counts, what's going in. And we can also see here in monitoring that we're monitoring kind of the same data. This is a little bit, it's been running this whole time, so it's a little off, but you can see we're getting the same logs in Azure as we were getting locally. which is nice. And now you're probably wondering, I kind of cut off around the logic app portion. So if a bus is activating a logic app, remember, we're going to call the HTTP request that sends it to the Azure Logic app, and we're going to call it with those two values, and then we want to send an email. So let's look at how easy that was to do with logic apps. So this is my logic apps. You can see this is the logic app designer. It's drag and drop. It's very easy to find things. If you want to add a new step, you can see there's lots of connectors that you can leverage. And but in this case, we're just going to look at what we have. So we have this HTTP request that our Azure function calls, and it has to give two values. Remember, we talked about those two values it's going to bring. And it's going to take those two values, and you can see I'm using the Outlook connector here, and it's going to send an email. It's going to say, hey, if you want to catch the bus, you should head to the bus stop now, your bus, and it's going to supply those values, so the vehicle ID, and then whether or not it's entering or exiting the geofence. And then I could even parameterize this to send it to specific users, but I'm just keeping it really simple here. So that's it, just this two-step logic app. And now I'm able to automatically send emails. And you can see I've gotten a few since this session started. So for example, I can see this bus is entering the geofence. So I can see that I should go head to it now. And you can see they've kind of been coming in all hours. So this is how we can take a look at the Azure Logic apps and using Azure Functions together. It was very easy to make this happen. I see one question here that I'm going to address now. It says, does a Logic app have multiple triggers? Yes, there are multiple triggers that you can leverage for Logic apps. There's literally like 250 or 300 different connectors and ways that you can trigger this thing or make it work. So something to look into. Definitely a really cool technology. Let me see if there are any other questions that are related to this. What are the prerequisites for this Learn module? You don't really need anything. We will walk you through in the module. So if you happen to take on, we do say there are some things that are useful. So being able to navigate the Azure portal, familiarity with different things, but ultimately we're gonna walk you through step-by-step whatever it is that you need, especially configuring your environment. So here I'm gonna take you through all the extensions I think you should have, as well as how to get the GitHub code and how to get set up in Azure Data Studio. So hopefully everything you have, regardless of prereqs, is there for you. So hopefully that helps. Let me see. I think that's good for now, but I can take some of these questions that are a little tangential a little bit later if we have time at the end. All right. So we took a look at a lot of things. We've done so much so far. We talked about how to run functions locally. We published them using GitHub Actions, just like we did for Azure SQL Database. We looked at Azure Logic apps, and we were able to monitor those results. So our architecture so far is, of course, we're familiar with this. Now we've kind of filled in this question mark. We're going to use Azure Functions to trigger the Logic app and send an email. We're also going to use Azure Functions to get the data into Azure SQL Database and process it to identify what should be triggered in an email. Now, the next part is around this application. We still don't have an application. So that's what we're going to get into now is how to build the application in this case with Azure Static Web Apps. So if we remember our requirements, we've checked off most of these except the website for monitoring real-time bus locations. For that website, we want to basically have a map with real-time buses in the geofence, and we want to be able to filter what's displayed on that map based on the monitored bus routes and geofences that are provided as an input or by a user. Now, some of you might be wondering a little bit about what static web apps are. Now, a big thing about static web apps is that server-side rendering is not required. And we're seeing a lot of these being built in Angular, React, Blazor, Vue. And for this, we used Vue to do this front end purely because we wanted to learn how to use Vue. We've been hearing a lot about it. This is JavaScript-based language. So if you want to learn about it, this is a good place to start as well. Now, for our solution, instead of using Azure App Service for hosting, we're going to use Azure Static Web Apps. And I really love Azure Static Web Apps because what it's doing is it's combining the power of static web application hosting with Azure Functions. So some of the stuff you already saw, we're now combining it all in one. And what that means is we can take in our code changes And with GitHub Actions or Azure DevOps, it's supported in both. I'm just only using GitHub Actions today. You can make it so that your static content, so your web page, is displayed and deployed at the same time your API or APIs using Azure Functions are displayed. Now, this is a relatively new service. It just became generally available maybe mid-May, so it's relatively new. But what's so great about it is how tight these integrations with, say, GitHub Actions are. So, for example, if I take a look, when I deploy an Azure Static Web App, it's going to create that GitHub Action workflow file. Those YAML files I've been showing you for Azure SQL Database and Azure Functions, you have to create those. But with GitHub Actions and Azure Static Web Apps, it creates all this for you. It's even going to create a connection to your Azure Static Web Apps and to your GitHub and kind of integrate your Azure and GitHub together so they can do a lot of the handshakes and pass-offs and you don't have to be involved, which is really nice. Now, there are two things that you are responsible for providing during deployment or post-deployment in this YAML file, and that's where your front-end application is located and where your API or APIs are located. So where in your repository. Azure Static Web Apps wants you to tell it, basically, don't let me guess, like tell me where your front end is and tell me where your APIs are. So just because it takes a minute to deploy, I wanted to take a pause and go ahead and deploy this Static Web Apps. And what you're seeing is here in this example, there are 3 different languages that you can use. And we're going to use the portal, but there's also an exercise if you want to do this all using scripts, you can do that as well. So what I'm going to do is I'm going to search for, all caps today, Static Web Apps. And in the marketplace, I'm going to go ahead and select it. That's going to allow me to create a new one. And then I'm going to be brought to this familiar workflow. I'm going to put it in my bus resource group. We'll just call it bus app. And the great thing here is you can pick 2 tiers, free, which is what I'm going to use, or you can pick standard, which is going to be able to auto scale and is more meant for your production workloads. I'm going to pick a region. Note you want to put this region as close to your database as possible. So I think my database is in East US 2. And then I'm going to use GitHub. Sorry, this always gets me. Being a Microsoft employee, I automatically get put in the preview Azure portal, and sometimes I forget that I need to hop into the actual portal. So just bear with me 1 minute. I'm going to go through that again, but now you'll be a pro at it because you've seen it twice, right? That's how that works. So we're going to go into the bus resource group. I'm going to call it bus app. Again, we're going to use free. I'm going to put it near my database, and now I'm going to sign in with GitHub. So remember I said this is going to help me do all of those handshakes for me. Because I'm basically allowing GitHub and Azure to communicate without me having to facilitate that. So now that I'm in, I can specify my organization, my repository. So I forked the main GitHub repository. That's what you'll do as well. And then even the branch, and I can tell it what language this is. So those were the different frameworks I was talking about. They also have static site generators, or you can bring your own. I'm going to go ahead and select View, and then I'm going to specify where my app and database are. So that's where my app is in my GitHub repository, and this is where my API or my function is, which we'll talk a little bit more about later. I'm just going to go ahead and spin this up, and then we're going to actually talk about what's happening in this application because we don't know yet and how things are working. All right, so now that's deploying. Let's talk about what's happening in the Azure Static Web Apps and how we're going to display that data. Now, the first thing to consider is how is the front end going to be getting data, right? So how is the client UI, that's what I'm referring to as the front end, going to get the data? Well, it's basically going to call the backend API, so that Azure function that's built in, and just return whatever that backend API returns. We'll talk a little bit about what that backend is doing, but let's first talk about the front end. So this is just a quick look at the code. What it's first doing is it's going to look in the URL, and it's going to look for the route ID and the geofence ID. Again, one of the requirements, remember, was to only display certain routes and geofences, not all of them at once. So we're going to add some parameters to our URL. Maybe we can make this a little fancier in the UI later, but for this initial deployment, that's what we got. And then it's going to take that route ID and geofence ID and basically call the API. So we're going to call the API with that information, and then we're going to return whatever that API returns. Okay, so what is that API doing? So now we're looking at the backend API, which is going to call Azure SQL, which essentially has all the data we want to pull forward and ultimately show in the application. Now, all this data is in Azure SQL Database. We're just going to use a stored procedure to call it. We're just going to use, I think it's called get monitored bus data. But the tricky thing, or one thing to be careful of when you're working with different languages, is there are different libraries you're going to want or packages you're going to want when you're interacting with Azure SQL Database. And even trickier, your connection string required is going to change slightly based on what language you're using. So make sure that for whatever language you use, you select the right connection string. And you might say, well, duh, but I can't tell you how many times I was using the SQL Server connection string when I should have been using the Python connection string, and then, nothing worked. So once you get that, which is pretty simple, then you can configure that connection from your Azure Static Web App. And basically, we're going to call this stored procedure, like I was telling, and it's going to return all the different points that are in our monitored bus data, and it's also going to return the actual geofence. And this is going to make it super easy for us to surface. Remember how I was saying that Json support in Azure SQL Database allows us to specify how we want to return the data, and so that's what we're able to do here. All right, so let's take a look at how to put this all together. So I'm going to go back. Hopefully our application is deployed, so it has. So we're going to go to the application, and we can see a few things. So again, since it's tightly integrated with GitHub Actions, we can go straight into, straight into the main GitHub repository. We can edit that YAML file. So if we take a look at that, remember I told you it was going to automatically deploy this for us. So you can see it's gone ahead and deployed this for us. It's added these secrets to our repository, and it's taken in our app location and API location. Now, the other thing we can do is we can see the GitHub Actions runs. So just like we saw them for Azure SQL Database, they also exist for Azure Functions, and they also exist for Azure Static Web Apps. So you can see, for example, here what we're doing. And this one's actually pretty smart because it's able to detect the language of your application. So here it's saying, let me find it. So, okay, so it detects that my API was written using Python in this case. And then it's going to basically generate, download the right version of Python and all the requirements that I have for my application in order to deploy this thing and build it correctly. So that's pretty cool. It just takes care of that for me. The last thing is I can take a look at the actual application. It gives us some funky name, which you can change later. We can see it's just a map. Now, it's not displaying our Azure SQL Database data yet, but why is that? Well, that's because we haven't configured the connection string. Remember, I told you you have to tell the Azure SQL, you have to tell the Azure Static Web Apps how to connect. So I'm going to create a connection string, Azure SQL connection string, and we're going to make sure we use the Python connection string because that's what I use this time. But again, this is written in Node and .NET as well. So now we should be able to save it and go back to our application and refresh and see that information. Now we still aren't seeing it, and that's because, remember, we said we want to specify the route and the geofence ID as well. So now when I specify that and refresh, cool, what do we see? So down here, we see our geofence. I'll zoom in a little. We see our geofence. We see there actually are a few buses in the geofence right now, so I could go catch the bus. And we can also see buses that are nearby data points that are close by. It's only displaying the most recent 50, but we can see there are some near Microsoft West Campus and some probably getting pretty close. Probably a lot of chances for me to catch the bus pretty soon. So that's kind of what we took a look at. Again, all this is also, of course, you could go through the code for this. It's all in here for the Azure Static Web App. You see the API is written in 3 different languages, and you have the client application. All right, so we've seen a lot. Let me come back and let's take a look at the final architecture we came up with. So you've seen all this before, right? The IoT device, Azure Functions is sending the notifications and also putting data into Azure SQL Database. What we added was this Azure Static Web App, which combines the web application with Azure Functions. So that Azure function is simply calling Azure SQL Database to return the data to surface in our Azure Static Web App, which is then producing that website for monitoring the active buses. So hopefully that was cool. We've seen a lot of things and not a lot of time. You've really learned how in different languages you can kind of see the integration points between things like Azure SQL Database, Azure Static Web Apps, Azure Functions, Azure Logic Apps, and hopefully you're seeing how like Azure itself is really a big puzzle, and it's very interesting and useful to know how to piece these things together. Now, resources, you're probably wondering, okay, where can I get hands-on? So this first URL is going to take you to the learning path where, again, you can try all these exercises for free. You can deploy this application, play around with it. I challenge someone to go get the JSON data for the city they live in and update the application and submit a PR. That would be a cool update. We have a show on YouTube called Data Exposed. I stream every Wednesday at 9 a.m. Pacific, and we also release a bunch of on-demand episodes with people from the Azure SQL and SQL Server product group, so definitely want to subscribe to that. Should follow us on Twitter, and as Simon mentioned, myself, Davide, who wrote this sample, and a few other colleagues from our team, we actually wrote a book, and Simon's so nice to show his book, the book on screen, and read the bios from it. But definitely check out the book. I hope this is really useful for you all. Thanks so much for having me.